Welcome, pre-cal students, to the homework help video. We will try to get through this video. My voice is pretty rough today, so we will give it a shot and see how we do. So here we go. All right. Problem 103. The population of a town will double in this many years right here. Find t. Okay. So what I'm kind of testing you on here, not testing you, what I'm kind of testing you on is seeing if you know how to solve this, okay? It says very simply here to find t. Find t. Now, if we're going to find t, what is t? Well, it's right here. That's it. So the population of a town will double in t years. Find t. So all that we have to do is type this into our calculator. Now, here's how I would type it in if I were you, okay? I would be very careful about trying to type this whole expression into my calculator at once, okay? Because you can really make a mistake with parentheses and stuff like that. Plus, remember, every time you hit the LN button, a parentheses automatically pops up like that. So here's what I would do, okay? I would type into my calculator 10 natural log of 2 and hit enter. And get that decimal number off to the side, whatever that decimal number is, okay? And then, in fact, I'll go ahead and type that in real quick. 10 natural log of 2. And that's not what I wanted to do. Hold on one second. I'm on the wrong page here on my calculator. 10 natural log of 2. And you'll get this right here, approximately. And as long as you write down about 5 or 6 decimal places, you should be fine, okay? Now, then I would type in my calculator natural log of 67. Now be sure and close your parentheses, okay? Natural log of 67. Close your parentheses, minus natural log of 50, and then close your parentheses, okay? And you will get this right here, 0.29266696, okay? And then if you divide those two, you will come up with the final answer, which is approximately 23.7. So if you're trying to do research or know what kind of accommodations your city will need in the future, you can see right here that your city is going to double in about 24 years from now. Okay, so that's it. Here we're just taking how we learned to type natural logs into our calculator, and we're applying it to word problems. That's it. Okay, 105. Okay, this is pretty simple here. A principal P, that's the money you invest, is invested at this amount, and it's compounded continuously, and it increases to a K amount. Okay, excuse me, to an amount K times the original principal. Don't forget that phrase. It's real important. K times the original principal after T years. So here's what it means. You ready? It means every year, whether it be 1 year or 2 or 4 or 6 or whatever, this model here will give you out the amount of money that is that much times your original amount you invested. Okay, I'll show what that means in a second, a little bit later. So here's our model right here. First of all, complete the table. Well, guys, I'm not going to take time and walk you through this. Where K is, you put a 1. So natural log of 1, enter, divided by 0.095, enter. And then do that with 2. Natural log of 2, enter, divided by 0.095, enter. And you will get this right here. Let me grab my cheat sheet I have here. Okay, 0, 7.3, 14.6, 18.9. Most of you should know how to do this. It's pretty simple. 21.9, 24.2, and 26.2. All right, there we go. Now, it says interpret your results. Now, guys, be very careful. Look what it says here. It's not saying that in 0 years you'll have $1. It's saying in 0 years you will have 1 times. Look what it says. K times the original principal. Let's just pretend, guys. Can we do this, please? Let's pretend you invested $2,000. So we're going to pretend the principal is $2,000. So in 0 years, you would have 1 times $2,000, which is $2,000. which makes sense because it's been 0 years, so you haven't gained any interest yet. Now, let's see here. Hold on 1 second here. In 7.3 years, you will double your 2,000. So it'll be 2 times 2,000. How do I know that? Because right here, 7.3 years, K will be 2. Okay, now in 14.6 years, your new amount would be 4 times your amount that you invested. So you would have 8,000. Okay, and then one more. Let's jump up to this last ordered pair here. Okay, and here's T for time. In 26.2 years, you will have 12 times your original amount. So 12 times 2, you would have $24,000. So that's called interpreting your results. You're explaining to me what this means, okay? Now, sketch a graph. This is really easy, guys, to sketch a graph, okay? Very simple. Look, we already know we have a logarithmic function. We do, Mr. Earhart? Yeah, look, guys, watch. Watch this. Now, this is where you learn to interpret word problems and think things through. You already know how to graph this. T equals 1 over 0.095 times the natural log of K. That's the exact same thing as this. Look, if you were to put this over 1 and then multiply these two fractions together, you would get this, which is what you started with, okay? So now look what we have. This is a natural log expression. Here's a number out front being multiplied times natural log of K. So you know how to graph it. I mean, first of all, there's your argument's K. So you take your argument and you set it equal to 0 and solve, and that would be your vertical asymptote. So this is your vertical asymptote right here is 0. Okay. Now, what variable is all by itself? T. This is your t-axis. Natural log of K. This is your k-axis. Here's your vertical asymptote, and then plot your points. I mean, your points were what? It'd be 1, 0. So right here. And the next order pair was 7.32. And then your next ordered pair was 14.64. So you go way over here, about here, and up to 4. And that's good enough. You've got to get any idea, guys. It's going to be a curve. And it'll be a gradual curve. Okay? So there we go. That's all you have to do, graph. Look, guys, you got a bunch of ordered pairs here that you can plot. Just understand which one is your x-axis and which one is your y-axis, okay? And then go from there. All right? Okay, let's try the next one. Number 107. Okay, now look. This is a little more difficult, but it's okay. Here's your model right here. And it gives us x is the airspace per child in cubic feet, and y is the ventilation rate in cubic feet per minute. Okay? So, I mean, it sounds a little confusing, but it does make sense. Depending on how big a room is and how many kids are in the room, you have to have a certain ventilation rate so that the air keeps moving, so that we have a safe air quality. Okay? So, it does make sense. So, here's your model right here. Now, here we go. Use a graphing utility to graph the function. Okay, no problem. Let's do that, okay? Now here's what x falls in between, okay? So guys, go to your window real quick. Remember the window button? It should be the top left button right beside the y equals button. You know what? Let's clear your window. Go to zoom and hit 6. hit zoom and hit 6 so you're back to your normal standard window, okay? Now hit your window button. And look what I've typed into my calculator. Look up at the screen here. I typed in 100 as my minimum and 1500 for my maximum for my x. So look what I have here. Take a look at this. So in your window, go ahead and do this. Okay, now what I did, notice my minimum, instead of putting 100, I put 90. So I went a little bit lower than 100 to get a really good picture of the graph. And then notice, instead of putting 1500 for my max, I put 1600, just to give me a little bit more of a space, okay? Now notice that this has not changed and this has not changed, okay? You understand that? We're going to talk about that in just a second, okay? Now, let me grab this over here, slide this down. So let me review again. Let me get a drink here. Let me review again. What I've done here, guys, is I have typed in my x minimum and my x maximum based on my given domain up here. Okay? All right. Now, students, the next thing I have to worry about here is, what about my y minimum and my y minimum and my y maximum? In other words, how big do I want these values to be? Well, guys, here's what you're going to do. Think about it. Let's go to our, well, first of all, if you've not typed in your equation yet, go ahead and do that. Okay, so go to your y equals, hit y equals, and type in your function, just like it is, 80.4 minus 11 natural log of x. Now, after you've typed that in, think about it, guys. All that we have to do is put 100 in right here and get out a y value, and then put in 1500 right here, 1500 for x, and get out a y value, okay? So I did that, and go ahead and take notes on this if you want to, guys. I did that, and here's what I got out. I got out 100, gave me out 29.7, and 1500 gave me out negative 0.045. Okay, so look what that does for me. Now watch what that does for me. Now I can take my window. Did not mean to do that. Hold on one second. Now I can take my window here, and I can change my y values. Okay, so now I'm going to want my y value to be, okay, here's my y minimum. So my smallest y value is negative 0.045. I'm going to go a little less than that. I'm going to put negative 1. Okay, and then for my y maximum, I'm going to put 29.7. I'm going to put probably 35, 30, somewhere around there, 32, something like that, okay? And now go ahead and hit graph, students. Okay, go ahead and hit graph, and it should look like this, okay? It should look like this. Something very similar to this. And so what we're learning here, guys, is how to fill out our windows properly based on the information that's given to us, okay? So there we go. The graph should look something like that, hopefully, okay? All right, now let's continue on. Now, we did what we were told to do. We graphed the function. Now, they want us to approximate the ventilation needed if there's 300 cubic feet of airspace per child. So here we go. Here's our model right here. Now let's be very careful here and think about what does X and what does Y stand for. Okay? Now look, the required ventilation is 300, no, I'm sorry, we have 300 cubic feet of airspace per child. Well, let's see, X is the airspace per child in cubic feet. So that's your X. Okay, so all you have to do is put in 4x 300. Okay, if you type that in correctly to your calculator, we'll get out for y 17.66. Now don't forget what y is, okay? Y is the ventilation rate in cubic feet per minute. So cubic feet per minute. So there we go. So what we're learning here is a couple things. How to change the window in your grapher so that it fits the function that we're graphing. And then number two, you're learning how to decide which variable you substitute a number in for. Okay? Moving on to number 109. Okay, pretty simple problem here. Here we go. We're going to complete the table for the given function. So here's x. We put a 1 here and a 1 here, and we would get out 0. Okay? Then we put a 5 here and a 5 here, and we would get out a 0.32. And so on and so forth. So you would end up with 0.23 here, 0.04 here, and I'm not sure, here is 0.00092, and then here it was really small number, like 0.00000. I'm not sure how many zeros it was, but it's really a small number, and so I didn't fill that in. But anyways, you get the point, hopefully. So there we go. Okay, so we've used the table to determine what value f is approaching. F of x approaches as x increases without bound. So look what we did here, guys. Here's what they're saying to us, okay? They're saying to us that fill this table out, and we did that. And then they're saying, look, what is happening to f of x? Is it approaching a limit? What's it doing? As x is increasing like crazy. I mean, 1, 5, 10 to the 1, 10 squared, 10 to the 4th, 10 to the 6th, that's a million. 10 to the 6th is a million, okay? As x is increasing like crazy, what is y doing? Well, look, it starts off at 0, and it goes up to 0.32. And then look, it's getting closer and closer to 0. So, what value is f of x approaching as x is getting bigger and bigger and bigger? Well, it's approaching 0. Look, 0.32, 0.23, 0.04, 0.00092. So it's approaching 0. Okay, and that's called a limit, by the way. We'll talk about those later on this year. Now, use the graphing utility to confirm the result. Okay, here's what I did. Now look, guys, get your graphers out. Okay, first thing you do is you type this into your grapher. Okay, so I would hit the y equals button, and then hit natural log x, close your parentheses, then hit divided by, and then hit x like this. And if you do that correctly, it should look like this. Okay, so there it is. That's how you should do it, okay? Natural log parentheses x divided by x. Okay? Alright, now, next, you think that you have your windows figured out pretty well. I mean, your windows are right in front of you guys. Look, we can go from 1, the x, up to 1,000,000. So with my table of values, I did this. Now you can follow along if you want to and type this in, okay? For my window, I put, if you'll go to your window, I put 1,100,000. I went a little bit above it, and instead of putting 1 for my x minimum, I put 0. I went a little bit less than 1 and a little bit more than 1,000,000. Now your x scale here just means how much do you want each tick mark to be. And so I said, well, each mark on the x-axis will probably be about 1,000. Okay, so I put 1,000 right here for that. Now, for the y minimum, think about it, guys. Your values go from 0, okay, then they went up to 0.3. 0.32, then started working their way back down to 0 again. So my highest value up here was 0.32. So I went ahead and put 1 for my y max 1. Okay. Now my lowest value up here for my y's, or my f of x, was 0. So I put a 0 for my y minimum. Now this was a mistake. Watch what happened, guys, okay? Look what kind of graph I got out. And if you want to go ahead and type all that in and hit graph, you should get the same mistake that I got, okay? Here it is. Nothing, okay? So sometimes you got to do a little extra thinking on your own. It's like, okay, what is wrong with my graph here? So I got to looking at it, and it dawned on me, guys, think about it. Look, and you got to really think about this. Look, you've got 1 giving you out 0, 5's giving you out barely above 0, 10's giving you out almost 0.23, and then you go up to 100, 10 squared, and that gives you out 0.04. Then you go up to 10,000, 10 to the 4th power, and you go to 0.04. And so what you got to realize here, guys, is on this graph, when you typed in the window that said from 1 to 1,000,000, that means all along here you're from 1 to 1,000,000. That's why this line's so fat right down here at the bottom. What it is if you've got a really small graph here, because they're all bunched together from 0 to 0.04, and so it's all down here. So I said, okay, here's what I'm going to do. I'm going to take my X window and I'm going to do this to it. Instead of saying 1 to 1,000,000 and cramming all those points on there, I did this. I said, okay, I'm going to make it from 0 to 100. Why, Mr. Earhart? Because, guys, look, 100 is basically giving you out 0. 10,000 is basically giving you out 0. 1,000,000 is basically giving you out 0. Okay, they're all basically giving you out 0, so I don't need all these extra ones. So I kind of did this to spread the points out so I could see them a little better, okay? And then I went ahead and put my X scale back to 1, 0 to 100, X scale of 1, and then I went ahead and made my Y scale 0.1, because look, guys, my minimum is 0 for my Y, and my maximum for my Y is 1. So I want to have a little bit of space there, so I put 0.1 would be my tick marks for my y-axis, okay? Now when I entered all that in, here's what I came up with. I hit graph, and this time, and guys, remember, if I'm going too fast on this video, just have Mrs. Gallant or whoever the supervising teacher is just pause the video, okay? No problem there. And look what I got, a graph that looks like this, which makes sense. Remember how the graph started off at 0, and then as we went along, it shot up, and then back down. Okay, so my y-axis is running from 0 to 1. So all of these tick marks are like 0.1, 0.2, 0.3, 0.4, 0.5, 6, 7, 8, 9, 10. Okay, so 0 to 0 to 1. And all of these are going from 0 to 100. And all of these tick marks are 1, so they're really close. I've got 100 marks in here, okay? And so there's the graph. Alright, so does the graph verify the result that I said that we're getting closer and closer to 0? And yes, it does. Look at the graph, guys. As we go further out on the x-axis, putting bigger and bigger numbers in for x, the graph shot up, and then it's getting closer and closer and closer to what? 0. Closer and closer to the x-axis. Closer and closer to 0. Okay? Alright, moving on to number 111. Alright, now this one's pretty cool here. Now, I did forget to take a picture of the model, so I'm going to write the model down real quick here. So hold on a second while I turn over my book to wherever that is. Hold on one second. Page 476, I believe. Okay, here's the model in your book. If you'll look, you'll see this model right here. T equals, sorry for the yawn, 12.542 natural log of x over x minus 1,000. Okay? Close the parentheses. And there we go. Now, look what this model does for you. Okay? This model only works when you have a mortgage of $150,000. Okay? And the rate has to be 8%. Okay? So this formula only works when you have a mortgage of $150,000 and interest rate of 8%, which is really high, by the way. Okay, now T is the length of the mortgage in years. Okay, and X is the monthly payment in dollars. So here we go. Use the model to approximate the length, or in other words, the time of a $150,000 mortgage at 8%. So notice we fit these two characteristics, two qualities here that we need. And they tell us the monthly payment is $1,100.65 per month. So that goes in for X because it says here X is the monthly payment. So for X right here, I'm going to go ahead and put $1,100.65, and then here, same thing, $1,100.65. Okay, now guys, from here, to be honest with you, it's all calculator work. Okay, and there's really not a lot I can show you. I guess what I would do is I would type this whole fraction in first, right here. Okay, 100 or 1,100.65 divided by, and then put this in parentheses here, like that. Okay, and then whatever you get out, take the natural log of that. So you have 12.542 natural log of some number right here. Now, if you do all of that correctly, you should come up with 30.00055. So I'm going to call this a 30-year loan, which is pretty safe, or a 30-year mortgage. Okay, so we answered question number 11. Approximate the length of the mortgage. So it's a 30-year mortgage. Okay, now let's come over here. And slide this up here. Slide this down here. And now let's look at number 113, okay? Here's what it says. Okay, now approximate the total amount paid over the term of the 30-year mortgage with this monthly payment right here. Okay, now we know they're paying this month here per what? Month. Okay? And we know they're doing that for 12 years. So take 1,100.65 times 12. Now when you multiply that by 12, you're getting out how much they pay in a year per month times 12. So then multiply that by 30. So at the end of 30 years, they will have paid this much here. $396,234. Okay? Now, what is the total interest charged? Well, guys, how much was their mortgage? $150,000. That's how much they borrowed. So that's how much. That's how much they were going to pay for the house. So that's how much the house cost. But look how much they ended up paying. So how much interest did they pay? Well, subtract out the $150,000, and you will see they paid $246,234 interest. Okay, that's a lot, and that's why whenever possible, students, if you're able to pay off your houses early, it will save you a lot of interest. Okay, so here's how much the house cost. Here's how much interest was paid. So here's the total amount they paid altogether over 30 years. Okay? Alright, moving on to number 115. Okay, first of all, let's see the median age in years of the United States population from 1991 to 2002 can be modeled by this model right here. Okay, where t is the time in years. Now notice t equals 1 corresponds with 1991. So we need to write that down, okay? So for 1991, you would put 1 in to the equation, okay? Don't miss that. For 1991, you would put 1 into the equation for t. Okay? Alright, moving on. Now, this model is good from 1991 to 2002, so we're going to say that t runs from 1, which is representing a representative of 1991, and it runs to 12, which is representative of 2002. Okay? Because again, don't forget, students, 1991 is represented by 1. Okay? Alright, let's continue on. Now, first of all, we're going to use a graphing utility to graph the model. So, if you type in the function into your calculator, it'll look like this right here. Hopefully you can see that okay. Alright, so there it is. You type it in just like it is. 33.06 plus 0.312, hit square root, put a t in, or an x, and then close your parentheses, and then hit natural log of x. Okay, you've got to close your parentheses after the square root of x. Okay, so it should look like this. Hopefully you guys can see this okay on the screen there. Okay, now next let's talk about our window. Now you know your x's are pretty simple, or your t. They've given it to you right here. Your t runs from 1 to 12. So for my window, I put, for my x's, I put, instead of putting 1 to 12, I put 0. That's a little less than 1. And I put 15, which is a little more than 12. Okay? Now, how do I know these in from my window here? Well, guys, I just put a 1 in for t and a 1 in for t like this, and I got out 33.06. Okay, and then I put a 12 in for t. Now, why 1 in the 12? Because remember, here's your range, your domain right here. Your domain goes from 1 to 12. Okay, so I put a 12 in, and I got out 35.7. So I knew that my range had to run between 33 and 35. So look what I put, guys. Instead of putting 33 for my smallest number, I just put 30, okay? And instead of putting 35.7, I just put 40 for my largest Y value, okay? So my window looks pretty good. Now let's go ahead and hit graph. And here's what it looks like. Something like this, okay? So there, we did it. Okay, not too bad. Alright, let's continue on. Now, it says find the median age in 1991 and 2002. Well, guys, we already did that right here. Look, we already did that. We already put a 1 in for 1991, and we already put a 12 in for 2012. Okay, so there really isn't a lot to do, or for 2002, sorry. So there really isn't more to do. Here's your answer for 1991, and here's your answer for 2002. Now, do you think the model would be accurate for years beyond 2002? Well, probably I would say yes. For a while, for a couple years, but not much longer after that, okay? Because remember, this model is based on data and information gathered from 91 to 2002. And why would the model not be used prior to 1991? Well, guys, the data that was gathered started in 1991. So really, I mean, if you try to make any predictions or prove anything from times before 1991, that's really not going to work, because your data you collected started with 1991 to 2012. So no, you really can't use the model. I mean, maybe for 1990, maybe, but that would be about it, okay? All right, moving on to the next problem. Okay, number 98. Okay, here we go. Students participate in a psychological experiment, attended several lectures. Every month for a year after the exam, the students were retested to see how much of the material they remember. The average scores for the group can be modeled by the memory model. This right here, okay, where t is greater than 0 and less than 12. Now notice, students, that t is in months. Okay, so notice that. And then here's their question. What was the average score on the original exam? In other words, no time had passed. Okay? Well, that means t would be 0. So, for t right here, we're going to put 0. like this. Okay, now let me grab my calculator real quick. And I probably should have had this done already. I apologize, but here we go. Let's see what we got here. 90 minus 15 log 0 plus 1, just 1, enter. Okay, and what you're going to get out, students, is 90. Okay, so that was the score. The original score was 90. Then they had the students come back and, hold on 1 second here, take the test again. So now we're going to put a 6 right here for T, okay? And now let's see what the average score was, okay? So here we go, put a 6 in for T, and you get this. So 6 months later, because the human memory is not perfect, and we forget things, 6 months later, the same students took the same test, and their average was a 77%. Okay? So again, we're just learning how to take given models, given functions, and then evaluating the variables at certain numbers or at certain values, okay? All right, number 99. The relationship between the number of decibels P and the intensity of a sound I in watts per square meter is given by this function here, okay? Use the properties of logarithms to write the formula in a simpler form. Okay, we know how to do this, guys. Remember, when an argument is a quotient, we can split it up into 2 logarithms. So we can say there's a 10 right here. Don't forget that 10. And then put parentheses or brackets, okay? So 10, then a bracket, and then logarithm, base 10 of the top, which is I, minus the logarithm of base 10 of the bottom, 10 to the negative 12. Okay? So there we go. Now look, guys, real quick, look. This is where all of your properties come in. They're so important. Look. Whenever your base matches the base, the entire expression is the exponent, okay? So we really have, bring down your negative sign here, and then this whole expression here equals negative 12. Okay? And then negative and negative makes it a positive 12. Make it a really big plus sign, okay? And then, of course, you have a 10 here we can multiply through. So we get 10 logarithm base 10 of I plus 120. So there we simplified it pretty well. Now, determine the number of decibels when your sound intensity is 10 to the negative 6. So for I right here, I'm going to put 10 to the negative 6. So I have 10 logarithm 10 of 10 to the negative 6 plus 120. Well, guys, you don't need your calculator. Look, whatever the base matches the base, your answer is just the exponent. So I'm left with 10 times negative 6 plus 120. So negative 60 plus 120 gives me 60 for my answer. So there we go. Again, it's really not that hard. We're just taking past principles we've learned, laws, and how to substitute numbers in and stuff like that, and just apply it to word problems, okay? All right, last problem and we're done. Okay, here we go. Use the graphing utility to graph each of these and see if they're identical. Okay, let's start off with the letter A right here. Now, students, you really should see right away, hopefully, that this here is the exact same thing as this here. Okay, remember, whenever you have an exponent here, you can move that to the left of the logarithm like they did here. Now, what they want you to do, and students, go ahead and hit your zoom button and hit 6. So you go back to your standard window, okay? And then go to your y equals, and for your first y equals, hit natural log of x squared. Go ahead and type that in. And then jump down to y2 and type in 2 natural log of x. Now, when you're done doing that, look at both of your equal signs. Both of your equal signs should be highlighted. If they're not, you will want to move your cursor over to the equal sign that is not highlighted and hit enter. Make sure both equal signs are highlighted. Now, here's why you're doing that. When you highlight both equal signs, you're saying to the calculator, I want you to graph both of these at the same time. So go ahead and do that and hit graph. And I don't have a picture of that, but you're going to see both graphs will fall right on top of each other. Okay? It will look like this. Something like this. If you're in a standard window. Something like that. Okay? And then the other graph's going to fall right on top of it. You won't even be able to see it because they're identical. Okay? And that's all they want you to do. Okay, same thing for letter B. Right here, same thing. So we have f of x equals natural log of this right here. G of x equals 1/2 natural log of x squared plus 1. Now, these are identical, okay? Look. We've learned that whenever you have a radical like this, a square root, that's the same thing as writing it to the 1/2 power like this. Okay? And then we've learned whenever you have a power in your argument, you can pick it up and put it right here, which is what they did over here. So these two expressions are identical, and if you go ahead and hit y1 and type this in, and then hit y2 and type this in, and then hit graph, you will get the exact same equation, okay? And let me real quick type this in here to give you an idea of what it'll look like. X squared plus 1 graph. It should look something like this. Hit here, and then come up like this. Now, if you'll make sure that both equal signs are highlighted and hit graph, the two graphs will fall right on top of each other, okay? Okay, so that's it for today. I know the video's been pretty bad with my voice, but again, we'll go as far as we can this year, doing the best we can. So if you have any questions, don't hesitate to call or email. And I hope this homework help video has been a help to you guys. Make sure you understand the math. You'll be responsible for this math on the quiz coming up this Friday, okay? All right, have a good day.